Hello students, let us discuss preparation of ethers in this video. The two methods of preparation which we want to discuss here, which are dehydration of alcohol, the second one Williamson synthesis. So let us discuss these method of preparation one by one. First, dehydration of alcohols. As we have already discussed this equation, that is alcohol on dehydration, that means removal of water, give rise to alkene. But the dehydration of alcohol can also give rise to ether. That is, alcohols undergo dehydration in the presence of protic acid such as H2SO4, H3PO4, etc. to give either alkene or ethers. The formation of product that is alkene or ether depend upon the reaction conditions. For example, when the alcohol is heated with H2SO4 at 443 Kelvin, then alkene is the product. But when it is heated with H2SO4 in the temperature 413 Kelvin, at the time ether is the major product. That means here the reactants are same, but the reaction conditions is different. That is, one of the reaction is taking place at this temperature. At the time alkene is the product, but when the reaction is taking place at this temperature, then ether is produced. So in this video we are going to discuss the reaction of alcohol with H2SO4 at 413 Kelvin, which give rise to ether. So we are going to discuss this reaction. The first reaction we have already discussed in the previous chapter. So we are going to discuss the second equation. So let us write the general equation for this one. How we write the general equation? That is ROH. On dehydration, that is in the presence of protic acid, it gives rise to ROR. You can check here. This should be taken as 2 times here. So this R, O, and again this R comes. So how you can make easily product? That is ROH becomes ROR, where R is the alkyl group. Now let us discuss the mechanism. Mechanism of this reaction can be explained in 3 steps. So let us discuss the step first, that is protonation of alcohol. Here we have taken ethanol. So protonation means addition of H plus. So the H plus get added here. So what we get the product, that is protonated alcohol is formed. You can see H get attached to this oxygen and the positive charge is on oxygen. So that is called as protonated alcohol. So first step is the protonation of alcohol. In the second step, that is the nucleophilic attack by another alcohol. This is the protonated alcohol which is formed in the first step. Now another molecule of alcohol, it attack here the protonated alcohol because there is a positive charge on the oxygen, and here there is a lone pair on oxygen. So there is a nucleophilic attack takes place that result in the formation of that is this compound, which is called as a protonated ethoxyethane, or which is also called as oxonium ion. This is actually protonated ether. Why? Because when you compare this part is ether and having plus H, having positive on oxygen and H, that is protonated ether, which is called as oxonium ion. So oxonium ion is formed in the second step. In the third step, deprotonation takes place. That means removal of this H positive. H positive get removed. That is called as deprotonation, removal of proton. That result in the formation of the product, that is ether. So this is the 3 steps By this, there is a formation of ether from alcohol. That is first step. That is a protonation. Protonation gives rise to a protonated alcohol, which further on the second molecule of alcohol, when further react with this, it gives rise to a oxonium ion, and which on deprotonation give rise to ether. So that give rise to what? The formation of ether takes place from alcohol. This is called as dehydration of alcohol, because there is a removal of water, which is you can find in the second step. So due to the nucleophilic attack of the another alcohol molecule on protonated alcohol give rise to a oxonium ion, plus there is a removal of water here. So elimination of water is taking place. Therefore, this process is called as dehydration, that is removal of water. So it results in the formation of ether. Second method of preparation of ethers is Williamson synthesis. This is a reaction which we have already discussed in the chapter first of organic. The Williamson ether synthesis is the most widely used method to produce ethers. It occurs by the SN2 reaction in which metal alkoxide displaces a halide ion from alkyl halide. Let us write the general equation, that is Rx plus NaOR dash give rise to ROR dash plus NaX. Look at the equation here. It is an alkyl halide. What is this one? This is called as a sodium alkoxide. That is, we are using generally metal alkoxide word here. So when that metal is sodium, we can call it as sodium alkoxide. So when the halide react with sodium alkoxide, so there is a removal of NaX here. That means the removal of NaX. So what will be the main product? That is R is left here, O is left here, R dash is left. So RO, R dash, where R and R dash are the different alkyl group. It can be different or it can be the same alkyl group. So what is result here? It results in the formation of ether, that is RO, R dash. So very easily you can frame the product. What you need to do, you have to write the ether or halide in such a way that these two comes together. So any one of this you can write it in the reverse order so that you can easily frame the product. So let us do one example. This is one example given, that is this is actually sodium alkoxide. How? Because this is sodium and this is all part together called as alkoxide. The alkyl group and O, alkoxide, and here there is a alkyl halide, that is CH3 CH2Br. I told you how you can easily frame the product. You write one of the compound in the reverse order. So I am writing this in the reverse order, that is Br CH2 CH3. I am writing the alkyl halide in the reverse order in this way. Now I can easily frame the product. Look at the equation. Here Na and here Br get removed. That is NaBr is removed. Now what is the remaining one? What is the remaining part? This is all part and this part get combined. So you can find out this much till here and here. This get combined. So what you got here? That result in the formation of ether. So what you need to do here, you have to make the arrangement in such a way that you can easily frame the product. In such a way means Na and the X part should come closer. So better you write one of the molecule in the reverse order so that you can easily frame the product. So this is the formation of a ether. Let us take one example. In this example, you can see 1 degree alkyl halide, that is primary halide is used in order to prepare the ether. So here you can find out how the product can be formed. This Na and this Br get removed. So Na and Br get removed. So this part get attached to this. So we'll get this ether. So this is the case of primary alkyl halide. That means it is more preferred to prepare the unsymmetrical ether by using primary alkyl halide, because when we use secondary or tertiary alkyl halide, so instead of undergoing the preparation of ether, it undergoes the preparation of alkene, which is shown here. In the second equation, you can see that instead of forming ether, here alkene is formed, because the reason is the first in the reaction substitution is taking place, but in the second, that is the reaction of tertiary alkyl halide, result in the formation of alkene. Here elimination is taking place. That means the better result are obtained if the alkyl halide is primary. In the secondary and tertiary alkyl halide, elimination competes the substitution. So when you compare the two equations, here the primary halide is taken and here tertiary halide is taken. So in the case of primary halide, we are getting the product ether, but in the case of tertiary halide, instead of getting ether, we are getting alkene as a product. Since here substitution is taking place, here elimination is taking place. One question is given in the text, that is a solved question is given in your textbook. This question is, the following is not an appropriate reaction for the preparation of tertiary butyl ethyl ether. That is, this equation is given. So this is not actually the appropriate method for the preparation of ether. How it is named? Tertiary butyl ethyl ether, because this part is called as tertiary butyl and this is ethyl. C2H5 is ethyl ether. So it's a common name given, tertiary butyl. It's a tertiary butyl. Why? 4 carbon are there. It's a butyl, but tertiary butyl ethyl ether. So this is not the appropriate method for preparing this by this reactant, because we have already discussed in this video that the tertiary halides, instead of undergoing substitution, what it undergoes elimination reaction. So the elimination takes place. So definitely ether will not be the product. So what will be the product? So first question is asked, what would be the major product of this reaction? So what will be the major product? That is an alkene. Elimination takes place. Look at here how the elimination takes place. One Cl from here and one of the beta hydrogen. So you can remove this hydrogen. So HCl get removed. So what will be the other one? It will be form an alkene. That is, alkene is formed because of there is a formation of double bond between the alpha and beta carbon. So here there is a formation of double bond. So what will be this called? So now this is a propene, because Cl is removed here. It's a propene. And on the second carbon there is one methyl group. Once again I will frame the product here. Remove the Cl and remove one H from here. So there is a formation of double bond here, that is between the alpha and beta carbon. So this is now called as propene. And on the second carbon there is one methyl group, so that is 2-methyl propane. That is the alkene which is formed in this reaction. That is a major product. So the answer for first is, that is, the major product in this given equation is 2-methyl propane. Because as we have discussed here, the sodium ethoxide is a strong nucleophile as well as the strong base. So the elimination reaction predominates over the substitution. So instead of substitution here, elimination takes place. That is, a removal of HX takes place. So this results in the formation of alkene. So the second part of this question says, write a suitable reaction for the preparation of tertiary butyl ethyl ether. So because this method is not the suitable method, so how we prepare this? So we need to write a suitable equation for this. We can, instead of taking tertiary halide, we will take a primary halide here, and this part, that is sodium alkoxide, that can be taken as a tertiary. So when you do this reaction, this will give rise to ether. Because why? This is a 1 degree alkyl halide. So 1 degree alkyl halide can undergo a substitution. So here there is a removal of Na, here there is a removal of Cl, and this part you need to write on this side. Otherwise, I told you, write this in the reverse order. This I can write in the reverse order, that is Cl, CH2, CH3. Now you can remove Na from here and Cl from here, and this part get binded here. So that result in the formation of this product, that is tertiary butyl ethyl ether. That result in the formation of the ether in this way. So it is one of the most important question also, that is usually asked in the exam, that is especially in the board exam. In the case of aromatic ethers, we can prepare aromatic ether first when the alcohol is treated with NaOH, give rise to sodium phenoxide. Here phenol is react with NaOH, give rise to sodium phenoxide plus Rx. Again, this is a reaction of with a Williamson reaction. So Rx. So here there is a removal of X from here. Na and X get removed. So there is a formation of ether. So the formation of ether takes place in the case of phenol. From phenol we can prepare ether. So that is all about this video, in which we have discussed the preparation of ether, that is from Williamson synthesis and from dehydration of alcohol. So have a nice day.